A fractional exponent means that you have an exponent that is a fraction. So in that, you have n, which turns into your index, and m, which is just an exponent. And the way that we type this into a calculator, you have to be able to do it both with a calculator and without. So to type it into your calculator to check, you would type your base, so x, yx, m, whatever your number is for m, a, b, c, and then equals, and that would give you your answer. So sometimes it will work for you, sometimes it won't. If you get a decimal, you have to do it without the calculator. You have to show your work no matter what. Okay, for the first example, m is equal to 1 and n is equal to 3. So our index is 3. We have the square root of 27 to the power of 1. When it's to the power of 1, that just means it's itself. So now we're just going to evaluate. So 27 is the same as 3 times 3 times 3. So it's a perfect cube. So the cube root of 27 is 3. So that is in simplest form. For example B, m is equal to 1, n is equal to 2. So we have the square root of 49 to the power of 1. 49 to the power of 1 is the same, so 49. And 49 can be split into 7 times 7. So the square root of 49 is 7. For the next one, m is equal to 1, n is equal to 4. So if you put this into a radical, it means it's the 4th root of 16 to the power of 1. 16 can be broken down into 2 times 2 times 2 times 2. Since we have 4 2's, the 4th root of 16 is 2. And if you are unsure of how to find that, you could just evaluate the 4th root of 16. m is equal to 1, n is equal to 2. So we have 12 is our base. It's a square root, and it's to the power of 1. Now, if you take the square root of 12, it's not a perfect square. So we're going to break this down to 4 times 3. And 4 is a perfect square. It's the same as 2 times 2. So 2 times 2 times 3. We have 2 2's, we can bring it out, and we're left with a 3 on the inside. So we have 2 root 3. For example, E, our m is equal to 3, and our n is equal to 2. So this is a little bit different because m isn't 1. So our index is 2. Write our base, or radicand, and to the power of 3. So type in 4 to the power of 3, and you get 64. And the square root of 64 is the same as 8 times 8. So in simplest terms, we have 8. 27, m is equal to 4, n is equal to 3. So we have the cubic root of 27 to the power of 4. 27 to the power of 4 is 531,441. And if you take the cube root of that number, you will get 81. M is equal to 3, n is equal to 4. So we have the 4th root of 81 to the power of 3. 81 to the power of 3 is also 531,441, as we've seen from the last example. And if you take the 4th root of that, you will get 27 this time. And on the last one, we have m is equal to 3 and n is equal to 2. So we have the square root of 15 to the power of 3. 15 to the power of 3 is the same as 3,375. Now we Since we know that there's 3 15s, 15 to the power of 3, quickest way to do this is 15 times 15 times 15. We have 2 15s left over, so we can bring one out. Then we have the square root of 15 left on the inside. And because 15 can't be broken down anymore, you know that this is in simplest terms. Now we're going to take them from a radical and put them into an exponent. So for this one, our index is 3, so n equals 3. And because 5 isn't raised to anything, our m is 1. So we have 5 to the power of m over n, so 5 to the power of 1 over 3. M, n are our variables. When there's nothing in front of the radical sign, n is the same as 2, because it's a square root. Our m, therefore, is 4. So, x is our 6, our radicand, is equal to m over n, so 4 over 2. And 4 divided by 2 is 2, so you could also write 6 squared. M, n, our index is 3, and our exponent is 2, so 2 to the power of 2 over 3. Our index is 2, our m is 3, so we have 3 to the power of m over n, 3 to the power of 3 over 2. So that's how you do the last two examples.